In this video, we're going to learn about the electron configurations of ions. So the principle that we're going to go by here is that atoms will gain or lose valence electrons in order to leave them with a full outermost s and p subshell. So um, that means that if we have, say, aluminum, which has 13 total electrons, it will either have to gain 5 to be like argon or lose 3 electrons to be like neon. And actually, there's really only one option. It's easier to lose 3. So it will become a positive 3 ion and it will have neon's electron configuration in the positive 3 state. Magnesium with 12 electrons will easily lose the 2 valence electrons in the s subshell and also become like neon in that they will have the same electron configuration. Sodium will go positive 1, um, and fluorine will go negative 1 because it has 9 electrons. And so if it gets an extra electron, it will have 10, just like neon. Similarly, oxygen will gain 2, nitrogen will gain 3. These are all isoelectronic because they all have 10 electrons and they will all have the electron configuration of Ne, 1s2, 2s2, 2p6. Now let's consider, say, a transition metal like iron positive 2. So iron normally would have the configuration Ar 4s2 3d6. And if it loses 2 electrons, normally we say that the 2 highest energy electrons are removed, which would suggest that they get removed from the D. But actually, within the D block, we're going to assume that all of the elements in the D block actually lose their S electrons first. So if we have a positive 2 ion, I'm just going to get rid of the 4s electrons, and the electron configuration of Fe plus 2 is actually argon 3d6. Fe also forms a positive 3 ion. This is common among the transition metals and also the inner transition metals in the F block. They often will have more than one oxidation state or more than one positive charge that they can take on. And so Fe plus 3, I would look at it like this. Well, we definitely have our Ar, 4s2, 3d6. Now we know the first electrons to go are the 4s electrons. Okay, fine. But if we need to take a third electron off, I guess that just leaves us with 3d5. So that would be the electron configuration of iron plus 3. Go over another example with you, which is for germanium plus 4. And germanium being over here has the configuration Ar, 4s2, 3d10, 4p2. Oops, there we go. And so it will lose 4 electrons. It's going to lose its 4p electrons because they are in the valence shell and they are the highest energy electrons that it can lose. But after losing those p electrons, then come the s electrons. So actually, germanium plus 4 has the configuration of Ar 3d10. And just to be clear, germanium with a positive 4 charge should go from having 32 electrons to having 28. Well, if we count here, 18 for the argon and then 10 more for the 3D, that gives you the 28 electrons that you'd expect. So that's all for this video. Hope it's helped. Feel free to leave any questions in the comments section below, and thank you for watching.